We have, in this example, the area of the region, or the region bounded by the curve square root of minus x plus 4 on the interval from 1 to 3, and the other boundary is the x-axis. And this time we need to revolve this around the y-axis. Now with this particular shape, we have to do a vertical slice because depending on where you locate, if you tried to do a horizontal slice, depending on where you locate that slice, the right edge and the left edge, or the right edge at least, would be different. So to be able to do this with one slice that will be consistent top and bottom, no matter where we locate that slice in the region in question, we have to have it vertical. Now the problem is when we revolve this vertical slice around the y-axis, we don't end up with a washer or a disc like we have in the other revolution problems. So bear with me while I try to sketch kind of what this looks like. When this vertical slice is revolved around the vertical axis, you end up with something that looks kind of like this. Okay, it's hollow in the middle. Imagine a soup can. Okay, and I can actually do a little bit better job of sketching what that looks like. If I kind of cheat and use the tools that I have. So you ultimately get something that's shaped kind of like that. And if you imagine several or a bunch of different slices in that yellow shaded region, and they're all revolved around the y-axis, you get a bunch of cylinders that kind of nest and fit together. This is why these are called cylindrical shells, which is why this is called volume by shells. Now what we've got to figure out is a way to approximate the volume of that one cylinder, when the one shell that we get when the vertical slice is revolved around the y-axis. So think about it this way. If we take a pair of scissors and cut right from the top straight down to the bottom, and then sort of think about unrolling that soup can and laying it flat on the table, we'll end up with something that's shaped like this. Okay, or a rectangular solid. And we're approximating the volume of that rectangular solid. Well, think about what we need. We need to know the length of the rectangle, the width of the rectangle, and how thick that slab is. Well, the thickness of the slab is always going to be dx, or delta x. The width of that slab will correspond to the height of our shell, of our cylinder, which in this case is going to be the square root of negative x plus 4. So the height will equal square root minus x plus 4. And then the length of our rectangle is going to be the distance around the circular base of the cylinder. In other words, it's going to be equal to the circumference of that cylinder, which would be 2 pi times the radius. Well, the radius of our cylinder, if we go back to my kind of bad drawing on the diagram, the radius is going to be measured from the axis of revolution to the slice. So in this case, the radius is going to be x. So this particular volume of this particular slice can be found by multiplying 2 pi times x times the square root of minus x plus 4, and all of that gets multiplied by delta x, or dx. So if we want to calculate the volume of the entire three-dimensional solid when that yellow shaded region here is revolved around the y-axis, we'll integrate this volume from 1 to 3, because that's the interval we're looking at. So pull a constant 2 pi out in front, have a definite integral from 1 to 3 of the product x and square root minus x plus 4 dx. Now, that particular definite integral is not one that we could do without the calculator. That's not one that we could do at this point in our studies by using the fundamental theorem. We don't know how to anti-differentiate x times square root of minus x plus 4 yet. But to generalize, what we're looking at here, which we're going to call the shell method, is volume is equal to 2 pi times the integral from a to b of the radius times the height times dx. In this example, we want to take a look at what happens when we revolve the curve the region bounded by y equal x squared, x equal 1, and y equal 0, which is the region I have shaded yellow, when that region is revolved around the line y equal 2. Now, if we work this with with a vertical slice, that slice would create a washer. In this particular lesson, we're working with shells. So I'm going to ask you to, even though we could do a vertical slice, let's make it horizontal. And I have solved the equation for x for our curve, because when working with horizontal slices, we have to have equations in terms of y, so they're solved for x. So if this makes a shell, here are the things we need: the radius, the height, and the thickness, of course, is going to be the width of our slice, which in this case would be dy. No work to figure that out. Now, radius. Measure from the axis of revolution to the slice. So we need to find the length of that little red arrow. Well, that length is going to be 2 minus y. Now let me explain. The distance from the x-axis up to the slice is y. The distance from the x-axis all the way to y equal 2 is 2. So if you take that entire distance and subtract y from it, what's left is the length of the red arrow there. So the radius of this cylinder would be 2 minus y. Now, height seems a little strange also when we're looking at a horizontal slice. The height that I'm talking about is actually going to be the length of the slice always. So with a horizontal slice, it's the right edge, 1, minus the left edge, which would be the square root of y, determined by that curve. So volume for this solid of revolution can be found by setting up the integral and integrating 2 pi, definite integral. The lower limit is 1, lower limit is 0, upper limit is 1. And then we have the radius times the height times the thickness. Let's look at another example. Same region. So we still have the curve y equal x squared, or x equals square root of y. We'll figure out what we need there. We still have the line x equal 1. Intersection point, still 1, 1 if we need it. This time, let's revolve around x equal 2. So let me draw my axis of revolution. And I'm going to label that so I remember what it is. To create a shell, we need to do a vertical slice. Okay, pretend that's vertical. Let me try again. Better. We're going to need radius, height, thickness. Okay, thickness is dx. Height is x squared, because it's the height of that slice, top minus bottom. So it's like x squared minus 0, but writing minus 0 doesn't do anything for us. Now the radius this time needs to be measured from x equal 2, from x equal 2 back to the slice. So this time the radius is 2 minus x. The distance from the y-axis to the slice is x. The distance from the y-axis all the way out to x equal 2 is 2. So if you take the entire distance and subtract x, that leaves you with the radius of our cylinder. So this volume can be calculated by taking 2 pi times the definite integral from x equal 0 to x equal 1 of the radius 2 minus x times the height x squared dx.